Hi everyone, this lesson is a chapter 5 review for trigonometry. So let's get started. And this is my sharing with you, this is my favorite picture, one of my favorite pictures of my daughter, Chelsea, that's her. And this was a movie she did with Steve Carell called The 40-Year-Old Virgin. So anyway, I like that picture. So we're gonna start off with true false. And so true false, this is asking me secant of 2 pi over 3 is equal to 2 pi 2 times root 3 over 3. So I'm going to make a little graph here. And 2 pi over 3 is over here. That's at 120 degrees. And if this is 120 degrees, you know that's 60. We have across from 60 is root 3. You have this is 2, and this going to the left is -1. Now, secant is reciprocal of cosine. Now, if cosine is adjacent over hypotenuse, then secant is going to be hypotenuse over adjacent. So 2 over -1, which is going to give me not this, but -2. So this one is false. The period of the graph here, so something to remember about sinusoids, that being a sinusoid, is that sinusoids have a period of 2 pi. So period is equal to 2 pi over the frequency. Period, this right here being my frequency, all right? So we're going to say that this is 2 pi divided by 1 over 4. So division is going to be multiplying by the reciprocal. So I'm going to take 1/4 and multiply by 4 over 1. And so 4 times 2 is 8 pi. So my period is 8 pi, which is correct. So that answer is true. The period for this graph, though, is 8 pi. What you need to remember for this is that the period for tangent and cotangent is pi. So pi divided by my frequency. In this case, my frequency is also 1/4. So this would be equal to pi divided by 1/4. You're going to multiply by the reciprocal, and so that's going to give you 4 pi, not 8 pi, but 4 pi. And so this would be false. For the next one, it says, convert 5 pi over 12 to degrees, and you're going to get 75 degrees. Well, for this problem right here, there is a formula you can use, and I'm going to give that to you. Theta equals 180 over pi times x. Now, that's a formula that we use to convert back and forth from radians to degrees. This being a radian, that's your x. So you would plug that in right here for x. So you'd say theta equals 180 over pi times x. Well, x is 5 pi over 12. Pi's are going to cancel. 12 divides into 180 15 times. 15 times 5 is 75 degrees. So this is correct. So my answer is true. And the last question here is asking me for the arc length created by 45 degrees radius of 5. And they're asking me, is it equal to 225 degrees? Well, the arc length, if you remember, arc length is equal to arc degree over 360. All that is a fraction. Arc degree over 360 times 2 pi r. So we're going to plug these values in that we have. Arc degree is 45, so they gave us that. So 45 over 360 times 2 times pi times my radius. My radius is 5. 2 times 5 is 10. 10 is going to cancel with this 0. 9 divides into 45 5 times, and 9 divides into 36 4 times. So my arc length is going to equal 5 pi over 4. Now, they actually asked me for a degree, and I can use this formula again to convert it into a degree. You may do that, or you can just use common sense. And 5 pi over 4, 4 goes into 5 one time. So technically what we have here is over 1, that's 1. See, 5/4 is 1 and 1/4, right? Remember, we don't write that like that. We're just using that as a reference. Where are we? Here's 1 and 1/4. Now, 1/4 of the way over, how many times does 4 divide into 180? Well, that's going to be 45 times. So 1/4, so 1 and 1/4. So we have 180 degrees plus a 45 degrees is 225 degrees. So that's also true. So if theta is an acute angle and cosine theta is 1 over 5, then that's what tangent equals. Well, let's see. If this was acute angle, you need to remember all acute angles are in the first quadrant, because acute means less than 90. So if theta is acute, cosine meaning adjacent over hypotenuse. So this extra value over here is going to be what? 25 minus 1, which is the square root of 24. Let's reduce that. The square root of 24, that's 4 times 6. So we're going to go square root of 4 times the square root of 6. So that's going to be 2 root 6. So I'm going to fix this root 24, and I'm going to make that 2 root 6. Okay, they want to know what tangent is. Now remember, tangent is opposite over adjacent. Well, opposite over adjacent would be 2 root 6 over 1, not over 5. So that's incorrect. So that's a false statement. An angle coterminal with 50 degrees is 310. Coterminal means that they end in the same place. So going up, here's 50 degrees, 50. Now, remember, where's 310 degrees? 310 starting at 0, goes all the way around and stop. Okay, it's still 50 degrees away, but coterminal means they end in the same place. Well, this angle that ends here, which is 310 degrees, does not end in the same place as 50. So that's false. Now, this is asking me for a phase shift. That's going to be a horizontal shift, okay? This is pi. It says it's pi units to the left. Well, remember that when you're looking for a phase shift, you see this number right here? That cannot be in front of your x. Your x cannot have any numbers in front of it at all. So we're going to say y equals 3 sine. We're going to factor that 2 out. So factoring that 2 out, I get x plus, now remember, factor means divide. So that means I'm actually dividing out a 2. So divided by pi divided by 2, okay? And so now look at it. This is the right way you would write it. Is there a pi unit shift to the left? No, it's actually pi over 2. So this is, again, a false statement. The exact value of cosine of 17 pi over 4 is this value, negative root 2 over 2, true or false? Well, something to remember about cosines and sines for 45-degree angles. Regardless of which quadrant we're in, the base value for a cosine or a sine, the base value is root 2 over 2. Now, depending on what quadrant we're in, right, will depend on whether the value is positive or negative. So we're looking for this. Now, 17 pi over 4, how many times does 4 go into 17? I believe it goes in 4 times with 1/4 left over, correct? Okay. And what that does is, remember, we don't actually write it like this, never write it like that. But what that does is it gives me a reference to where I am. So watch, so four times around, I'm going 1, 2, 3, 4, and now I got to go a 4th. Now here I am at a 4th, right? This is going to be a 4th, which is a 45-degree angle, 1, 1, square root of 2. Cosine is adjacent over hypotenuse, so that's going to be 1 over root 2, which is root 2 over 2. So in this quadrant right here, in the first quadrant, cosine is actually positive, not negative. So that would be another false statement. Now this is a great question. I really like this question. This one is saying, let me erase this right here. This question is saying, find the range of this graph. Now remember, we have 3 cosecant 4x. I always suggest that when you're graphing these, you change that cosecant as a reciprocal of sine. So I'm going to change that to a sine of 4x, okay? And then when I'm all done, I'm going to change it back to a cosecant graph. So what I'm seeing here, all right, is a sine wave. Now let's think of our VAF. Now we talked about VAF graphs before. So vertical shift, amplitude, F frequency, H horizontal shift, P is period. So I don't have a vertical shift. My amplitude would be 3. That's that height of that graph of a sine wave. My frequency, which is what in front of that X, which is a 4. I don't have any horizontal shift. My period is going to be 2 pi over 4. And so that's actually going to be pi over 2. So that means because I don't have a horizontal shift, I'm not going left or right, I'm just going to make my period, here it is right there, pi over 2. That means that my entire graph starts and stops within that domain, within that area from here to here. It's a sine wave right now before I change it. So we're going to go up 1, we're going to go down 1, and there's my little parent graph with a new period. Now, remember, this is 1. So remember, this 3 right here is going to mean I'm going to go up 3, down 3, and end here, right? Okay. Now, what you do here is basically you take your graph, right? And I'm going back to cosecant, and my cosecant is going to be, remember, these are my asymptotes here, crosses where my graph crosses the x-axis. So my new graph, see that right here? So this right here, there's one of my cosecant little parabolas, and here is my other cosecant little parabola, okay? So what that means is, remember, we went up 3 here and we went down 3 here, so -3. So your graph does not have this here. Your graph does not have this here. Your cosecant graph is just those 2 values here. What we did with the sine waves is just help us graph this. Now, the actual question here is asking us, what's the range? So that's what it's asking me. What's the range of this graph? Now, remember, when you're finding the range, you're always going to go low to high, low to high. And so low would be -infinity to stop here. That's going to be -3, and it's including -3. Union going up 3 bracket 3 to infinity. Okay, and that's always a parenthesis on that end, okay? So this problem right here says, solve the triangle given that A is equal to 30 and B is equal to 50 degrees. So if, A is equal to 30, not degrees, but just the number 30, and that's a length. And B, beta, is 50. So what we're gonna do is I'm gonna draw my little graph here. I'm gonna say this is beta, this is B, let's call it B. And that's going to be 50 degrees. I'm going to call this A. We know that's now 40, and we'll call that C. So to find the other sides, we know this is little a, so that means that side is 30. This is little b, and this value is little c. Okay? To solve this triangle, you have to find all the sides and all the lengths, the measures, etc. So we know that the measure of angle A is 40 degrees. You could say that. The measure of angle A is equal to 40 degrees. Okay, that's done. Now we have to find little b. Now I would suggest, because I'm trying to find little b, and you don't have a calculator. So without a calculator, you would say, well, I can say tangent. So I can go tangent of 50 degrees is equal to opposite over adjacent, which is 30. Okay, so I'm going to do some cross multiplying, and so I'm going to say b is equal to this times that. So 30 times tangent of 50 degrees. So without a calculator, that's as far as I'm going to get. Now to find angle C, I'm going to still stay here at B. Now I could have moved to A, but I'm going to stay at beta. I'm going to stay right here. To find little c, what I'm going to do is I'm going to use cosine, because that's here. I'm going to use cosine. So we're going to go cosine of beta of angle B, which actually I'm just going to plug in that value because I know that's 50. So cosine of 50 degrees is equal to adjacent over my hypotenuse. And I'm going to cross multiply. I'm going to get c times cosine of 50 degrees equals 30. I have now c is equal to 30 divided by cosine of 50 degrees. So this right here is what c equals. Now without a calculator, that's as far as I'm going to get, okay? Now this problem right here is asking me to find the complement and the supplement. So the complementary angles add up to be 90 degrees. If I'm in radians, right, then complements add up to be pi over 2. So the complement is going to be pi over 2 minus pi over 7, okay? And the supplement, which is 180 degrees, is pi. So that's going to be pi minus pi over 7. So just to simplify these, for this one, I'm just going to multiply this by 7/7. So my supplement will be 6 pi over 7. So that's what that value is. And this one, I need to get a common denominator. All right, so I'm going to multiply by that. So I have 7 minus 2, which is 5 pi divided by 14. Okay, and that's my complement. Given that, now this, I really like this question right here. Given that sine of theta is 2/3. Now, I would appreciate if anybody would draw a little graph here. You've got theta here. Here's theta. Now, the problem here is you notice that after reading the directions, it says I'm in quadrant 2. So I'm not in quadrant 1, I'm in quadrant 2. So let me redraw my graph. Okay, now I'm going to be in quadrant 2. And in putting myself in quadrant 2, I'm going to draw my little axis, okay, like this. I'm in quadrant 2. Here we are. There we are. Okay. And it says sine is 2/3. So here's theta. Sine is opposite over hypotenuse. So this value right here, I need that. So that value is going to be 9. Use the Pythagorean theorem. 9 minus 4, which is the square root of 5. And remember, that's negative going to the left. So your job here is to find the 5 function or all the functions for theta. So you're going to go, we already have sine of theta. So sine of theta is 2/3. Check, we already have that one. So cosine of theta is going to be adjacent over hypotenuse. Cosine tangent of theta is going to be opposite over adjacent. So that's going to be 2 over negative root 5, which is going to simplify to be negative 2 root 5 over 5. Okay, then we have cotangent of theta, which is the reciprocal of this value here. So that's going to be negative root 5 over 2. Then we're going to have secant of theta. Secant is the reciprocal of cosine, so that's going to equal negative 3 root 5 over 5. And lastly, we're going to have cosecant of theta, which is the reciprocal of sine, which is 3/2. Now, the only other thing that I might ask you on the test is basically what's theta? And so you ought to know how to find that. So to find theta, right, you're going to move this over to the other side. That becomes arc sine of 2/3. Okay, and so without a calculator, that's as far as you're going to get. So for this one right here, number 4, it says, given that cosine of theta is negative 1/2. So for this one, you actually need to think about where is cosine negative in a 2 pi period, okay? So when you're looking at that, you're thinking, well, all students take calculus. Cosine, I'm looking for where it's negative. It's positive here, so that's out. It's positive here, so that's out. So in these two quadrants, sine is positive and tangent is positive, which basically means that cosine is negative in both of those quadrants. So in this quadrant, let me draw my little angle here. Okay, cosine is negative 1/2, which means this is going to be a root 3, right? Where am I? Well, I'm at a 60-degree angle. This value here, from here to here, is 120 degrees. That in mind, I still can be down here also at a 60-degree reference. So that's going to be 180 plus 60, which is 240 degrees. And the last question is number 5. It says, where is cosine equal to 160 degrees? This is another question very, very similar to what we just did in this problem. I'm going to draw a little axis, and I'm going to draw myself 160 degrees. So here I am, okay? 160 degrees, I have a 20-degree reference angle. Okay, so in this quadrant, cosine is negative, all right? Ask yourself, where else is cosine negative, okay? Cosine is not negative here, and it's not negative here. So the only other place that cosine is negative is in this quadrant down here. So if this here is 160 degrees, there's your 20. This also has to have a reference of 20. So this will be 180 plus 20. So the other angle has to be 200 degrees. All right. So we're going to start doing a few other problems that are that you might see on your exam. You're riding a Ferris wheel, which constantly rotates. So, your Ferris wheel definitely looks something like this, right? Where you've got your wheel, then you've got this little area where you're standing off the floor, right? So let's see what they give us. They give us 10 seconds after you start your stopwatch, you've achieved your maximum height. So that means that after 10 seconds, we'll just say this is 10, we're at our maximum height. This is my time, okay? It says that, and that maximum height appears at 70 feet above the ground. 20 seconds after you are at after that, you are at your minimum height. So 20 seconds from here, 10, so 20 seconds, okay? So if that's 10, here is another 10, and here's 20. So this is 10, this is 10. Now I'm here at my minimum height, and my minimum height is 10 feet off the ground. So what I've seen is I have a high point and I've got a low point. So what I would like you to remember is this, okay? That a cosine wave starts high, goes down, ends high, right? So what we have is basically this high point and this low point right here. We have the high point and we have the low point, which is basically half of my graph, okay? So think about that. If that's the case, okay, and I've got basically half of my graph, okay, then this is 10, 20 seconds later, now I'm at 30, right? Okay, so this distance here, which is 20, is not my period because that only gives me half of my graph, right? My graph is going to keep going and end over here. So technically, if I'm writing my VAF, if you've been watching VAFHP, so my vertical shift, okay, I need to find that. Okay, I'm gonna move these numbers down here. Let's see, not that. No, I'm gonna move these down. Oh boy. Okay, I'm just gonna erase this and start over. Okay, so I'm gonna write my VAF down here, V-A-F-H and P. My vertical shift, remember how to find the vertical shift? It's the average between your high and your low. So that's gonna be 70 plus 10 divided by 2. So that's going to be 80 divided by 2, and that's going to be 40. So that means that here at 40, I have my midline. So that's 40. So there's my new sinusoidal axis, okay, at 40. So that means that's my vertical shift. Now my amplitude is this distance from here to here. This is the distance here. So that's 70 to 40. That's going to be the absolute value of 70 minus 40, and that's going to equal to 30. So my amplitude is 30. I'm going to wait on my frequency. I'm going to look at my horizontal shift. Now, where I want to start at a high point for cosine, so this is where I want to start. So that means I have a shift right of 10 seconds. And lastly, my period, if half of my period is 20 from here to here, then my entire period is going to be 40, okay, 40 seconds. So basically, you're going to use your period to find your frequency. So you're going to go, period is equal to 2 pi over my frequency. Well, I know my period is 40. So that's going to be 40 is equal to 2 pi over my frequency, which means that my frequency is going to be 2 pi over 40, which is going to be pi over 20. So that's my frequency. And I need that in order to write my equation. So now my final equation, if we wrote it in the VAF graph, which looks like this: y equals vertical shift plus amplitude times cosine frequency times x minus h. Now keep in mind, different people do this differently, and the v also could be written at the end of the equation or the front of the equation. So choose which way you like the best, and it doesn't really matter at all. Okay, so what we have here is y is equal to, now just plug in the values that you have. Vertical shift, 40 plus 30 cosine frequency, which is pi over 20, times my horizontal shift, which is going to be x minus 10. So this is my graph, or excuse me, this is my equation of my graph. Okay, I'm good. So I could also write another equation if I wanted to. Totally fine, I could do that. Let's do that. Just for fun, let's do that. Another equation, let's make this a sine wave. I mean, I completely could make this a negative cosine wave and do this, right? But let's just, for fun, make this a negative sine, because sine, usually starts in the middle, goes up, goes down, right? Ends at 0, starts at 0, ends at 0. But this would be a negative sine wave. And the shift, remember, would also be different. All the numbers would be the same except for those two things. So I could write y equals, my vertical shift still 40, but this would be minus, right? 30 sine pi over 20, still the same, times, shift is different, x minus 20. And so there's my negative sine wave. One thing that I would ask you also is, if my highest point is here at 70, when is my next highest point, which is over here? When is that? How would I find that? So if I started at 10, right, and I know my period is 40, 10 plus 40 is what? 50. So that means that my next highest point is 50. So I might ask that. And then from there, what if I started at 50 and I said, well, when's my next highest point? So then you would take 50, right, after 50 seconds, and then you would add another, 40 again, all right? So that's what you would do. So this one, we're going to do a little bit of sinusoid review, okay? This one is a cosine graph. Here's my vertical shift, amplitude, frequency, okay? I don't have a horizontal shift. I like to write my VAF on the side, okay? You don't have to do that. You're welcome to. My vertical shift is 1. My amplitude, which is in front of my sinusoid, is 2. Frequency is going to be pi over 2. Horizontal shift, unknown. And my period is 2 pi over my frequency. And if my frequency is pi over 2, what I have is 2 pi divided by pi over 2, which basically means that if you think of it, 2 pi divided by this is going to be 2 pi times 2 over pi, which my pi's are going to cancel, and my period is just 4. Now, if you're looking at this equation here, where's 4? Well, we can figure that out, because technically 2 pi is 6.28, right? Pi is about approximately 3.14. And so 4 is going to be in between here and here, right? So it's going to be around, I would say it's going to be around here, because what would be my average? 6.28 plus 3.14, 234, is going to be what? 9.42. If I divide that by 2 to get the midline, which is going to be, right around 4, I could get about 4. It's not going to be, this is 3, 4, 5. I think 4 is going to be closer to here. Wouldn't you agree? All right, so we don't need to do that. So 4 is going to be about here, so I'm going to say that's 4. So that means that's my period. And since I don't have a horizontal shift, that's where I'm going to start. Now, a regular cosine wave starts high, ends high. Halfway in between, we're going to have a low point, which means that my graph is going to do something like that, okay? Now, the different couple things that you need to realize is that I do have a vertical shift of 1, which means that my sinusoid has shifted up 1 unit, okay? So there's 1. There's my new sinusoid, okay? And it shifted up 1. Now, I can redraw that. I mean, there's a couple things I can do, or I could just do that. That also is nice. But the problem now I see is that my amplitude is 2. So basically what that's telling me is not 1, but 2. So it's going to be, you're multiplying by 2. So up 1. You're still going to go through here, 1, 2. You're still going to go through your axis, up 1, 2. So there's my amplitude. So my graph now is going to do this. Okay? So I took care of my period is 4. I didn't have a horizontal shift. My frequency changed my period. My amplitude is 2. My vertical shift is 1, so we've covered all the bases. So what you need to know is the domain, my domain is going to be from negative infinity to positive infinity. My range, okay, we got the amplitude, which is 2. I know my period, which is 4. But the range is a little bit tricky, right? That's your high to low, or excuse me, low to high. Actually, you should say that the right way. So what we know is that from low to high, my range, okay, low value is -1, including that value, so it's a bracket. And my high value is going to be 3. So -1 to 3 is going to be my range. So these problems right here, if we just did this one actually. So I'm going to omit this one because we just did that on the previous page. But I like this problem here. So this one says if tangent of theta is -√3. Now remember, tangent is opposite over adjacent. So really, that's opposite over adjacent, right? So I'm going to erase this so I can draw in between here. So I'm going to draw a graph. And it says that tangent is between 0 and 360. And this looks like it's a positive root, right? So therefore, I'm going to think all students take calculus. So tangent is positive in which quadrants? 1, so here and here. So that means it can't be down here and it can't be down here because that would make it negative. So we're going to draw my graph here. And I'm saying, well, tangent is opposite over adjacent. So this is 1. Let me erase this so I can get that out there. So there's 1, opposite over adjacent. So that means this is 2 here. So what I want to know is, where am I? Okay, across from the √3 is going to be a 60 degrees. Okay, or you could say, well, that's pi over 3. Where else? So it's going to be down here. So that also will be a 60-degree reference. But to get there, you're going to go 180 plus 60, which is 240 degrees, okay? And if you were using radians, you would go, that's 1 pi plus a third. Well, what's 1 plus 1/3, okay? So that'll be 4. So that'll be 4/3 pi, okay? Now, this was asking you, cosine is positive where? Okay, so we know that cosine is positive. Let's do all students take calculus. Here and here. So these are out. Tangent is negative in what quadrant? This one. Okay. So which one has cosine positive, these two, and tangent negative? So that's out. So that would be quadrant 4. Okay. This one says, so I'm going to draw a new graph, and I'm going to say all students take calculus. Sine is negative, so it's not here and it's not here. Okay. And tangent is positive. Well, that's this quadrant. So that's what, 3? So 1, 2, quadrant 3. And I'm going to draw one last graph, and I'm going to say all students take calculus again. Now, cosine and tangent are both negative. Okay, so where's cosine negative? Not here, not here. And where's tangent negative? Not here, it's positive there. So now we are in quadrant 2. So this one, I want to write an equation for this graph. Okay, so this looks like it's either a secant or a cosecant graph. So what we're going to do is we're going to connect, right? We're going to connect. I see these look like asymptotes here, right? So we're going to connect this and this right here and go down. Let's try to get this done. Okay. And so it looks like I have an asymptote here at pi. All right, that's pi. And I've got another asymptote over here at negative pi. So what I want to know is, how long did it take for my graph to complete one cycle, right? How long? To me, it looks like 2 pi, doesn't it? So this looks like it's a sine wave. If this is a sine wave, right, what's the reciprocal of sine? So that's going to be cosecant. So this graph is a cosecant. Couple of other things. What's my vertical shift? So we got VA, F, H, P. I mean, it really helps if you do the VAF, I think. My vertical shift, again, this looks like the height is 4, and this down low is -2. So that means to find the average, I'm going to go 4 plus -2 divided by 2. So 2 divided by 2 is 1. So that means my vertical shift is 1. 4, 3, 2, 1. So here's my vertical shift. Okay. So that means that this graph actually doesn't have that part to it right here, right? Okay. All right, so this goes up like that. Okay, so now we've got an amplitude. So what's my amplitude here? This looks like it's 1, 2, 3. All right. My frequency is just 1, and the reason is because I've got a high. See, this is my actual graph here. I have a high and a low in the 2 pi period. So that just means my period's 2 pi, I have 1 frequency. And a vertical shift, or a horizontal shift, I actually don't have one. So therefore, my graph is going to be y equals 1 plus 3 cosecant of x. Now, again, you can rewrite that as y equals 3 cosecant of x plus 1, and you can put this graph, you can put this equation, you can change it up and put the 1 behind it, and that's completely fine. All right. Now, I could change this graph. It's still going to be a cosecant graph. I'm going to keep it a cosecant graph, but I'm going to change that to, well, actually, we can change this to a secant graph if we start here, right? Because then you're starting high, right? And then you're going to end high over here. So you would have like the other parabola would be over here. Let's do that. And so that would just go like this. That would go y equals 3 secant, right? Secant of x plus 1. But I feel like I'm missing something. Yes, I'm missing the horizontal shift. So let's fix that, okay? For y equals secant of the quantity, right? The quantity x minus pi over 2, and then plus 1. So that's kind of a tricky question. I like that. There's so many different possibilities for that one. Okay, so here's a secant graph. Here, a secant graph is a reciprocal of cosine. Remember that? So VAFHP. So I'm going to write my VAF. My vertical shift is up 2. There's my vertical shift. 2. My amplitude is 4. My frequency is 1/2. I have no horizontal shift, and my period, because it's a secant, it's going to be 2 pi over my frequency, which is 1/2. I'm going to multiply by the reciprocal, which basically means now my period is 4 pi. Well, this graph doesn't go up to 4 pi. So this is what we're going to do with that. Okay, it's gone. So let's make my new axis. All right, so here's my axis. Okay, here's 4 pi, which means now that's 2 pi. Okay, so generally a graph, we're going to start, what is this? Secant graph is a reciprocal of cosine, okay? Generally, cosine graphs start high and high. So I'm just going to make a parent graph. Halfway in between, they have a low point. So it looks something like this, okay? Now, a vertical shift of 2 basically means here's 1, here's 2. Here's my new sinusoidal axis up here, okay, right there. So now my graph has shifted up like this, okay? Vertical shift up 2, so here's 2. Now, my amplitude is 4. So what that's telling me is that I'm going to have a high point. So 1, 2, 3, 4. So it's going to start high, still goes through here, right? Goes down 4. 1, 2, 3, 4. Still goes through here and high. 1, 2, 3, 4. So now my graph is doing this. All right. Now, something's off here. Oh, my period. So instead of a regular 2 pi period, my graph has a period of 4 pi. So that means that it is going to start at 0, just like this, and this is going to end high at 0. But halfway in between, I'm going to have my low point down here. And halfway in between here and here, I'm going to cross. Now, keep in mind, we still haven't graphed the actual graph yet. We're still pre-graphing, okay? So what we do have is this final wave. So what that means is let me show you. This graph is gone. This graph is gone. We have this happening. And where a graph crosses the axis, right here, okay, where the graph crosses the axis, those are my asymptotes, okay? So my final wave for secant is going to go from here. It's going to go up like this, right? Remember, you have to have two full parabolas. This one is going to go down that way and this way. And this one is going to come up here. Okay, so I know that you can probably use some sort of highlighter. I would recommend that you bring a highlighter for the test, or you can ask your teacher to borrow one. Okay, so that you can kind of make sure that everybody's got that down. Anyway, okay, so that's what my graph looks like. That's kind of cool, huh? Remember that it doesn't include this stuff. The final graph for secant is all this. And technically, we don't say that a graph like this has an amplitude, right? But we use the amplitude from a cosine wave